I did say I'm not gonna do today's stream, but I kind of felt bad about that, because that's not your fault, that's mine. I should have prepared a bit earlier. Then I might have noticed that earlier and would have been able to fix it in time. So this is gonna be a bit shorter, because we're only tackling a little topic that I can just improvise real quick. And yeah, next week is gonna be a bit longer instead. And what we're going to talk about today is a handy little interface that we're going to use all the time, knowingly or unknowingly, and that interface is called IEnumerable. IEnumerable. See, I need to pronounce that word correctly. I need to practice that stuff. IEnumerable. Whatever. Yeah, that interface is used in a lot of different other data structures that we're using a lot, and it's providing some very simple but very important functionality. And let's see some examples. So last time we learned about the list type, the default type we have. Let's call it just list. Using your list, and we can also pre-fill it using the object initializer 1, 2, 3. Now let's keep it at that. And we can also have an array. Let's also pre-fill it 1, 2, 3, like that. And okay, I can use the new collection expression, which does both at the same time, but let's keep it at the old style for now, so it's clear what I'm doing here. Actually, let's be very, very specific. Do it like that. And we could also do this with our own data types, like the linked list we looked at last time again. And what IEnumerable offers us is a way to run, for example, a for each. So in here I can put in a list, and value, list, and then make a console write line. Value is value, that. And right now we're iterating through the list. When I run this code, you don't see anything? Why do you not see anything? I just set this up, why is it not working already? Okay, that must be simple fix. Because it's that, oh, okay. Okay, so that's the default of the Windows capture. Let's do it like that. And you can see it better now. You can actually see it at all. Value 1, 2, and 3. And we got that from list, and we can do that for array. That's why we used that so far. Same code. And we get this output. And the reason we can use that in array and list, or we can use for each for array and list and a lot of other data types actually, is because they all share in common that they inherit, or no, that they implement IEnumerable. And IEnumerable has some very simple requirements. Let's create our own class that does it. Let's say public class some enumerable class, and it will inherit from IEnumerable. And okay, let's use the generic one because we're fancy like that. So right now this is not going to compile. We have an error because I'm missing the interface methods we should have. And I'm just going to use the features we have here to add them real quick. And we have one from Enumerable, basically, this one. So the basic version without the generic. And we have this one from the generic Enumerable. And this is the one we care about right now. Like this one, this is just basic code that can stay as is. We don't care about that. But this is the interesting one. It returns an IEnumerator for our class. What is Enumerator? That is a good question. Enumerator is what the for each loop here, for example, would use when we have, let's say, some enumerable class string. No, let's stick with ints. That's what we used so far. Our class equals blah blah blah, whatever. And our class can be put in here now. If it didn't inherit from IEnumerable, we might have a little issue. Because the for each doesn't know what to do with it. But because we inherit from IEnumerable, we have these methods. Let's put that back in here. And we can run the for each. Though you might have noticed something beforehand. We'll get back to that. If you noticed, don't worry, we'll get back to it. Hopefully. Now, the enumerator is what the for each loop will use to iterate through the values in our object. Be that an array, a list, or some other data structure like our own here. And so enumerable itself is just a way to tell us that this class, this structure, whatever we look at, has an enumerator we can use to look through data. So we're gonna need an enumerator. And when we do that, let's introduce a new concept. Nested classes. Because I'm still inside our class here. You can see the brackets. And I'm creating a new class right in here. Class Enumerator. That. And this is now a fully functional, legit class we can use. Like it's, in and of itself, it's no different from this class we have on the outside, or this class here, program. And we could even go further and have another nested class in here. We can do the same with structs as well. We can have structs in here and structs and methods and classes and structs, and could have enums, very special type of struct we learned about. We can all nest them in each other, and from the outside I can now use some enumerable class int like that, and then dot enumerator, and that would be now the full name to get to this class. You also see that I didn't write just some class or some class with a T. And I also didn't do this. No, because it's nested class, it will have access to some of the properties of the class it's nested in. So in this case, our class is a generic class, so our enumerator is automatically also tied to a very specific version of our class. For example, the int one, which is different from like the string one. Like these are both referring to this one class in here, but because the outside class it's placed in is generic, there are two different versions of it. It's similar to the situation with statics inside a generic class, where each version of our generic class has its own static instance or static variable. So in that case, they're a bit similar. Also, this is the only case in where it makes sense if you put this as private. So far we always use public because we want to see the class, but now we can do private. Private means it's only visible within the scope of this class. So on the outside, I can see it. Enumerator doesn't exist as far as I'm concerned from program. Can see it, but enumerable can see it, and here I can use enumerator. And this is quite common. You have some helper classes or structs or some structures that should not be used in other parts of the code, that should not be used by someone that's just using your class. You just have them internally to help you code your program. Like, they're just for your class to help structure your data somehow. But they're not meant for public use. Which has some advantages, like you don't have to worry about accessors in here anymore, because even if I put down something like public and integer, whatever, this field is perfectly visible inside our own class, enumerator.integer, but it's completely invisible on the outside since the class itself is invisible. And that also means I don't have to take some precautions when working with data, since the only code that will access this data is all contained in this class, and that's my class that I'm writing. So I can make sure the code is safe and knows exactly how this data is supposed to be used. If it was made public to the outside, so I just make this public, for example, and I have access to that in here. Okay, that's a bad example. Sorry, that's... Whoa. What the? To make that outside here, there might be issues with just directly accessing this data. There might be rules I don't know about that I did not put any safeties in the code in here. Right? That can happen sometimes, so this is very convenient, having nested classes and even private ones, especially the private ones, are very useful in many cases. And yeah, this is the situation now. We have our own class, which is IEnumerable, which just means this class will provide us with an enumerator. And this enumerator is right now just hidden as a private class inside our main class. Wait, something like that. Okay. Missed a click. And this enumerator itself now also has to inherit from enumerator. Let's do it like that, and I'm missing mouse, just like above. This one has a couple of extra ones. And again, super convenient to have an IDE, because I was too lazy to look up what exactly I need and to write that out. And yeah, let's leave it like that. Let's say new return new enumerator like so. Let's change this code a bit to just take current, cast it to t instead of having its own value. That's better. So let's talk about these specific methods. This one is a larger topic we haven't discussed so far. It's an important topic, but we're just gonna leave this method empty for now. I'm sorry, I hate when I have to do this, just accept that it's there and don't explain it, but it's complex. Like, there are rules in here that I want to take more time for. Just know that has to do with garbage collection and memory management that you don't have to do, but that is important. So it's just important that it's there. For us, it's not important that we actually use it. It just needs to be there and do nothing. These are also pretty self-explanatory, I think. We just have a property that lets us access this private object here. And actually, we're gonna later change this to something completely else. We're gonna remove this private object, but for now, that's also pretty straightforward. Reset and move next. They are the interesting ones. Let's have a little drawing, shall we? Because we can. Haha. Got the new setup ready. If you didn't notice the new look, you probably didn't, because it didn't look that different, but it's way easier for me now. I jumped down from about 12 scenes to just 4 right now. A lot more automation. And a lot less clicking for me, which means probably won't forget this time to close a window that's hiding the code while I'm talking about the code. Yay! Progress! Okay. Now in general, IEnumerable applies to everything that is enumerable. And that could mean, for example, we have a list of data, like an array. 1, 2, 3, 4, 5, 6, 7, 8. Or we could have a linked list. One that points to another one. 2 that points to another one. 3 that points to another one. And so on. Loosely connected objects. Or it could be some more complex object that doesn't even store all the different values, but just... Ooh, how do I draw this? Some complex object that's constantly generating new data on the fly instead of storing it. So maybe it's just starting at 1 and just incrementing it over time. And all these have in common that we would probably like to access this data. Either the data that's neatly arranged like this, which we could access using an index directly, but sometimes we just want to go through each item individually, one by one, to see the entire content. For linked lists, that's the only way we can look at the data anyway, but yeah, there too we would like to see all the data, step through all the different links, the different nodes. And especially for this one, where we don't even have a convenient way to look at any piece of data after the fact, because it only exists once in its entire lifetime, and then it will generate a new set of data. We also want to be able to see everything in here, all the values it can provide. And to unify the access to all these very different ways of storing or providing data, we have the concept of enumerators, which are like, in case of an array, for example, like a little window. So we have a little window that's 1, and to its left, on its right, there might be other values. We don't know. We can't see that. We can only see this one window. And in there we can see one single value. And then we have a little button that tells us to go to the next. We press that button and the window jumps over to the right, or maybe more like it moves the data in the background to the side, and suddenly this is now 2. In case of the array, or in case of the linked list, we don't know exactly what was before. We don't remember that data. We don't know what's coming next. We only know this is the value now, and this button lets us go to the next value. And we can only go forward. We can never go back. And at some point there will be a red light coming up. How did that look? Oh god. It was something like this. Trying to draw. Like big red emergency light, something like that. And it will let us know that there is no more data on the right. This is the last piece of data. So we can just continuously press the button, see every piece of data that's available. If it's stored, we just iterate forward by incrementing the index. If it's a linked list, we might go through to the next one by just following the link. If it's completely arbitrary data that's generated on the fly, we just instruct the system to now generate the next one. In all cases, we get a new value we can look at until at some point the system will decide, that's it, we saw all the data that there is, we're done. And that means for the array, we've just reached the last index, or the next link is going nowhere, or maybe the generator says, I'm done, I'm not capable of generating any new data. And so there's another button to reset everything. This button will just say, okay, we're aborting everything we have right now, and we go back. What just happened? Can you see the screen? Yeah, it's there. That's small. That's what she said. Okay. Enough of the quote-unquote humor. Center screen. Okay. So we go through all the items by pressing a button and see the next one in line. We get a notification when there are no more items, so we know pressing the button doesn't do anything. And there's a big red button for resetting everything, going back to the first item, possibly. It could also be that after pressing reset, there will be no more items. Could also be that this button will reset everything, true, but that means maybe deleting all the data. We don't know. And this is the enumerator. And IEnumerable, IEnumerable just means our object can provide such an enumerator that is custom designed for whatever data structure we have. So move next. That is our button to forward to the next item. And it's also our indicator light. This boolean will tell us, are there more items? Or is there a next item? Or are we done? It all depends on true or false. What do we get back? So that's our button to go through the items. And the items themselves are provided through a property, current. That's our window. Current will always give us the item that's currently visible in our enumerator, in our window. And in the end, we can press the reset button with the reset method. It's actually not that complicated. It's pretty simple. If it's just a simple list, it's very straightforward. Once we go to linked lists and some more complex data types, it can be a bit weird, maybe. I have some cases where I legitimately have to generate the data on the fly because the data is too big to store. So the only way to look at a particular set of data is by loading some data off the disk, doing some processing on it, not just decompressing, generating some additional data, and then provide that as a single piece of data to show, which then has to be quickly discarded to make room for the next, because otherwise it's impossible to hold all that information in memory. At least on the type of computer we have to run it on. I mean, if you have a Google data center, I guess that's not an issue, but it is for our customers. So yeah, going back to that, let's maybe try a simple example. Let's make a enumerator for an array to start with. Just something simple. And let's also make this generic since we added IoT data. And we just make a simple constructor that enumerable class data equals new t. Actually, let's make this like that. Let's be simple-minded. We just get the data from outside. Not the safest way to go about it, but it works. So we get the data and the enumerator. that we get is now supposed to go through that array. And we're going to combine a bit of the nested class logic now, because our enumerator will also have a constructor that's only visible within our IEnumerable class. See, that's why it's clever to put it in there. I have to now practice saying that word. So it is a private class, so only our IEnumerable class can see it. So this constructor is only relevant for that case. And we're gonna actually provide it with an instance of some IEnumerable class. I'm gonna just call it parent right now. And gonna make it like that. Make it a read-only field, so when I create this, I have to provide a link to the original class we come from. So when I get an enumerator, I actually have to make a link to us. I have to provide an instance that is us. And you already know the keyword for that. It's this. It's literally this easy. Just the keyword this. This is automatically a reference to this specific instance. Now we have an enumerator that knows the parent. It is its own class. I want to be very clear about this. It is nested in the code. So this class is written inside the scope of this other class. It's a nested class. But if you create an instance of enumerator, it is only this data it will store. And if you store an instance of some enumerable class, it will only store this data, this array here. They share space in the code, but they do not share any space in memory when you create them. Those are very different things. Written within the scope of the class, but entirely separate in memory. But because of the specific rules, because we're inside the scope of this class, we still have access to everything that's marked private within this class. So on the outside, our class.data doesn't exist. We can't reach it. Our data is private. But enumerator is written inside this scope and has therefore access to everything that's marked as private. So we can actually, for example, here. Oh, let's maybe do it here. Let's let's refer to current. No, not that current. Let's also remove that. Yeah, let's whatever. Can I do that? Why can I not? Why can't I? God, I hate interfaces sometimes. Okay, what am I doing wrong here? Is it just because of that? Yeah, okay, like that, whatever. So current will now refer to parent. Then we can use an index. So instead of storing the current value, we're just gonna store an index, current index. Like that. What am I doing wrong? Oh, sorry, forgot. My bad. Yeah, of course, like this. And actually, to be honest, it's probably better to switch that up for performance, I guess. So doing like that should be better. And then this is just current, then let's do that public. Can I switch that around? Honestly, I'm not sure about this anymore. Nope, have to do it the other way around. No, wait. Okay, so that works. So the fundamental issue is that these properties are both named current, and that has a conflict. It is one of the reasons why inheriting from two different classes at the same time is kind of not a thing. But you can do it with interfaces because you can specify where you want to get the data from. So I'm referring to the interface coming from Enumerator, and this one is just the one from Enumerator, but for generics. Yeah. Sometimes the weirdness is weird. All right. So this will give us the data at the current index, but current index has to change, and that's what we're going to do with move next. And what we're going to do here is current index plus plus. That's the first part. We just move ahead current index by 1 forward, so we can get the next piece of data from data. And we also have to include a value if actually no, not enough. Just a return. We have to tell the system if this is now a valid position, if we do have a next item. Then current index is less than parent.data.length. So if our array has only one item, the length will be 1, but the index is 0. If our index is already 1, it would be equal to the total length of the array, 1, and return a false. So as long as this returns true, we can look at current. Once this returns false, we can try to look at current, but it will be wrong, and in our case it will actually throw an exception. So the rule is move next to get next piece of data, but don't look at the data as if this doesn't return true. It's fine, we can look at it. And reset, pretty straightforward. Just go to 0. Like that. Now this is a very simple way to do it. I mean, it's probably better to have an if in the first place to check if there's a valid position and immediately return, because right now we're just constantly incrementing. And of course at some point you might hit a move next where we have an overflow and go to the negatives, where this will return true and this will return an error. Or potentially worse, this will hit the overflow, we go into the negatives, and then we'll continue to move next without looking at current, and actually go back to index 0, and actually everything starts to make sense again, but we're not at the correct position anymore. So this is not a good implementation, but it's one that works, and it should demonstrate what we're doing here at least. So now let's provide a new array. Integer 1, 2, 3. And in theory, if I didn't screw up, it should now properly show us 2, 3. Right. I did screw up. Yeah, right, because move next has to be called once before I even start. And that means we're going directly to index 1. Okay, so what we're gonna do? Current index. We're gonna start at -1, and just to be sure, return current index greater or equal to 0, and okay, so the overflow issue isn't there anymore. And, you know what? If current index greater or equal to parent.data.length, return false. So once we reach the end of the line, the last part of the array, we're just going to return false and nothing's going to change anymore until we hit reset, which is going to be -1 as well now. And actually, since we do that, we could also just call reset from here not always the best thing to do. So I'm gonna do it manually here, but I could do that. The reason you shouldn't do it always is because the logic might get changed here for one use case, and it doesn't fit the use case here anymore. So the constructor is very important to work correctly. You don't want the data to be refactored in a weird way. So depends on what you do. Like right now, it's a no-brainer. I can just change this and I'm done with it. No big deal. If there's a lot of stuff happening here, just calling the reset method is probably better. You just have to be careful that you can't accidentally, well, that you don't accidentally break the logic of the constructor by refactoring your reset method or whatever else you're using. Just a side tangent. Now, we're below the length, so actually, since we're doing it this way, we can start at 0 now. So if this item index 0 is already at the length of the array, if the array is empty, then we return false. And if not, we just, current index increment it and return true. So I'm not putting the plus plus up in here because I don't want the value to change if this condition is false. Okay, now it should show us 1, 2, 3. And I made a mistake again. Wow. Wow. Yeah, of course I still have to. Okay, now. Okay, come on. Seriously, what? Okay, sometimes programming makes me feel really smart. More often than not, it makes me really, gosh darn it, dumb. Okay. Why is... Okay, so now it should work. Yes, thank you, finally. Took long enough. Okay. This is why I rehearse stuff now, to notice issues like that. Okay. So a lot of extra code for basically just iterating through a simple array. Okay? Not the greatest idea, but it works. Now, what if instead of just having an array that has all the data, we do the other one? And actually, we don't even need to put that in here. Let's change this around. Let's do the one I had last example with the generating stuff. We don't need the index. We don't need the parent anymore. And no, okay, let's do it like this. In start, and end. Yeah, like that. And start, and let's copy that out here. Oh no, let's do it like that. Okay. So move next. Start equals start -1. Let's do that in here as well. Reset. Start equals. Okay, now we need a current. Yeah. And current. And let's make it a bit more fancy and not read only. What am I doing? Private bool complete. Yeah, like that. Now we can have current actually look at current. We're gonna remove the generic ones and just implement that as specific one. Because I'm lazy. So start is gonna stay like that was before, and current, yeah, let's keep it at 0 for now. Complete is false, yep. And also let's reset it here to default like that. And if complete, return false. That. So what I'm gonna do here is just have an purely integer-based enumerable with a purely integer-based enumerator that simply iterates through values from start to end. Once we're complete, we're done. Complete and false. Then actually let's current equal to start. That makes more sense. Like that, but I have to do the first. Let's do it like that, start -1. That should be -1. Okay, and then current ++. Let's put that in if current ++ equal to end. In theory, this should be enough, but mostly when it's about comparisons where I have to increment or decrement something, I always feel better if I have a more inclusive comparison. So usually it should end with the equals equals. In case of something weird happening, this greater or equals will ensure that we catch more than just equality. Current greater or equal to end. Current plus completed equals true. Return true. Yeah, like that. That should work. So this is gonna be a normal class. And we're gonna start at 1 and we go to 3, like that. And let's try the code again and hope it didn't work. Okay, so it iterated, but it didn't stop at the right time. Why current? And we can make a simple fix with just this, right? But yeah, okay, whatever. We can increase this a bit more. Let's say 30. And I didn't have to store 30 different values to just go through all these steps. I'm just using a foreach to iterate through this database structure, but this data structure, not database structure, and it will give me different values each time I ask. And when we call this code again, let me reset this to 3 once more. The iterator will vanish, or the enumerator. And down here we'll call a new one. So let's make a console output. Creating a new numerator. Actually, let's also put that up in here. Not here. That's fine, we create only one anyway. Then move next. Now let's next like so, and reset like so. So you can see when the methods are called without using the debugger. So we create a new numerator, we move next first, and we get a value of 1, move next, and then the fourth move next returns false. And so iteration is done. Move next returns false, we're not doing anything anymore, the next value is invalid. So in this case, it is actually a valid value we could read. We don't know that for sure. Move next said no. And then we create a new numerator for the next loop and use that one. We can also do everything by hand. And this might be important for certain situations. So let's do that. Instead of doing the second loop, we are doing this by hand, so we use our class.getEnumerator. This is an enumerator now. And we're just gonna ignore this warning for now, because I said we don't talk about that today. But yes, this is dangerous code right now. I'm doing a very important thing, not specifically to show you something. Enumerator.current would show us the actual value, but we have to check move next first. And because of that, we can simply use a loop. And then we can copy this value out. Put int value equals enumerator.current. We put that out, and this would work just the same as before. We can also try this again, enumerator.current, after we're done. So we can now, for the first one we don't have the enumerator, so we can check, but for this one we can actually check the value of current after we're done. And it actually worked. It was 3. Still the same value as last one because we never updated current, because this if kicked us out early. So if you do it by hand, you can actually check out the value. That might break things though. Now, what was the dangerous thing I'm doing here? Enumerator had this other special method down here that we left empty for now. And so for our specific case right now, this is actually fine. This is not hurting anything. But there might be scenarios where this method is important, where it's important that you call it, which you could just do manually, enumerator.dispose. But there's another way we can call it. And there are some safety considerations, like just calling it by hand on its own is not safe enough. But yeah, different topic for another time. But this is one way we can do this. We have a custom class enumerator that does something. It might generate data on its own. It might refer to a parent class to read data from there, like we did with the array earlier. And in the end, it's just a way to constantly get a new value piece by piece, which might be large set of data that exists all at once, or we generate it on the fly. Whatever the case, that's how we can get this stuff. There is, however, a slightly easier way for some scenarios, like this one, where I just want to iterate through the values from 1 to 3, which is a simple for loop, right? If a simple for could start with an integer I equals 1 and go up to including 3. Well, in that case, we can write a simple method that does almost the same thing. Call it public static IEnumerable int count. And from and to, like so. And here comes the fun part. We're just making a loop. Actually, we can keep from as is. Now let's do that as a separate variable for now. It's more readable, less confusing. Current from, current less than or equal to, and increment current, like that. And here we learn about a special keyword. Right now, I'm supposed to return an enumerable, right? So I would actually need to return you something with enumerable, like some enumerable class, for example. But with a special keyword, I can actually tell the system to not just return one value, but return a whole series of values and package it all together as one IEnumerable. And that keyword is yield. Yield. And now you got spoiled a bit because there are two versions of that. Yield can be put in front of return, like it suggests here. And that means it will return the value from current, this integer value here, but it will not return the method as a whole. It will basically in the background create a numerator, like we have here, that simply uses this value as current. So we are generating a series of values that get returned one by one in form of a very special enumerable that is constructed by the system for us. So we don't have to write our own class for that. For this case, it will sort of make its own class and put all the data in there. And the return just means this is one result for one move next. So if one were to call this method and get an IEnumerable, the first move next would result in current being filled with the first value from the first loop. And once that is done, once the value is read, then our loop here continues to the second item. We increment current by 1 and we call yield return again. Again, this is not return as you know it. This is not the normal return. This is yield return, a very special form. It's returning a partial value, if you will. There's only one part of the entire result. It's a bit weird, to be honest, but it's convenient. And I can actually leave it like that, and this will work, I hope. So let's ignore some class. What we have to do now is call count 1, 3, like that. And it will do the same we did before. We could also just store this in a variable as an IEnumerable. We could do the same with some enumerable class 1, 3, like that. We could do the same here as well. So that was possible all the time. Now we're just doing it with the method call, which will yield the values that we want to enumerate through. Let me call the code. 1, 2, 3. And let's maybe change this up to 13, 20. 10 to 20. There's the other yield we can use. We could put it in here for completion's sake, and it's called yield break. This is the kind of weird one. It's like the terms are reversed when you put a yield in front of it. So return is always the statement that would exit the entire method. If you see a return, that means this entire method is done. It doesn't matter what's coming after, it's done. And break is always, okay, we are breaking out of a loop or a switch case, but we're continuing on our code. So break is a softer form of return in that sense, in terms of termination. But if you put a yield in front of it, it's the exact opposite. Yield return will return a single value, but their method as a whole will continue. We'll have still more iterations going on. And yield break is the one that will terminate the method, that will act like a return. Like, return doesn't exist in this context. We can't use the term return. Like, this is a very special construct. So we have to use the yield break. You can, by the way, also just, let's make a separate one, public static enumerable int by hand. Let's do it like that. Yield return 1. Yield return 2. Yield return 3. And yeah, let's leave it like that. Maybe yield break just for completion. Like that. And we can call by hand. By hand. And 1, 2, 3. Every yield return will just return one enumerator value. And if I were to move this up, maybe up there, you can see the highlight is gone here. It's made a bit grayish, or a bit, how do you say that? A bit phased out, a bit opaque, whatever. In case we only go to 2 values, because this is, yield break is like a return statement, and yield return is a partial return only. The methods that return an IEnumerable have the special logics for yield possible. Only if you have a yield though. I can at no cost just have return, normal return, some enumerable class. Should add the new, like that. This is fine too. Like, this is still a normal method. Only when you add the yield will it become this special form of method. So I can return 1, only 1. Can also just yield return. Just skip the return, just have a yield break, and it's not doing anything. That's a bit weirdness here. And now one last thing, because I told you I would mention this again. Let's use some enumerable class 1, 3. So earlier, the thing that was a bit weird, maybe to you, I removed this. Now, of course, this complains because it refers to an interface that we inherit, which we don't inherit anymore, so this doesn't work. And this has no other conflicts, but let's remove this one for now. This code doesn't complain right now. And we can actually call it and execute it like normal. This is a bit special for the foreach loop. While it works on enumerables in general, it can also work with just the method getEnumerator that returns us an IEnumerator. So just having this method on its own will work for foreach specifically. And of course, we can call the getEnumerator to get an enumerator and manually step through it. So yeah. For each is special in that it can work with enumerables because it's looking for this method. If you have an IEnumerable, you are forced to have this method, but it will also accept it if you don't specifically say I inherit that interface. It will just assume the method works correctly and it's fine. Also, there's another special thing about for each. Just think it's kind of funny. If it's anything besides for an array, it will iterate through all the values with a bit more effort. It will use the enumerator and step through all the values one by one. If it is a pure array that we're feeding into it, the for each internally will actually change to a for loop with an index. I just think it's funny. If you use an array, even though arrays are enumerable, the for each will ignore the enumerable part and use indices if you step through an array. So, int array, let's just do an empty array. So this thing will actually generate slightly different code than if this was any other enumerable. And it's actually a bit more efficient. Just thought it's funny. For each is a bit special. Yeah, but that's it. That's enumerable. And that's enough for today. Just want to have a quick improvised session about anything, so I didn't leave without any stream. It feels weird now. I'm only doing this for a few weeks now. It already feels weird if I don't do a Sunday stream anymore. Hey, yeah, have fun with that. Look forward to the next time when we look at, spoiler, hashes and hash-based data structures. Alright, leaving you with that. Have a lovely day. Till next time.